Hey everyone, so in this video of clustering, we are going to take a deeper look at different kinds of hierarchical clustering methods. So before we do that, let's take a look at this notion of distance matrix. So anytime we do any analysis, we start with the data. Say X is the data matrix, right? So X has 3 rows and 1, 2, 3, 4, and 5 columns. Right? So in this case, we have n is 3, that sample size is 3, number of variables is 5, xi is the ith row, and say we are looking, and suppose we consider the Euclidean distance in our calculation. So there are different kinds of distances, but say we look at the Euclidean distance, okay? So we are going to see how to calculate distance matrix corresponding to this data matrix, okay? So this is the data and we are going to calculate the distance matrix based on this X. So first of all, so we have 3 elements, right? Each row is an element, so or a unit. So 1, 2, 3. So we have 3 elements, and so that's x1, x2, x3. First, we calculate distance between x1, x2, then x2, x3, and x1, x3. This is the formula for Euclidean distance. So we calculate distances between each pair of elements, right? That's what we have done. And then we are going to put all of these distances in a matrix form. So let's see. Okay, so this D matrix, so this is the distance of x1 from itself, that's 0. This is distance between x1 and x2. Let's look up. x1 and x2 distance was 2. This is the distance between x1 and x3. x1 and x3 is 1.41. Similarly, this is distance between 2 and 1. 2 and itself is 0. 2 and 3. 3 and 1. 3 and 2, 3 and 3. So if you notice that this distance matrix is symmetric as expected, because distance of 1 from 2 is the same, object 1 from object 2 is the same as distance between object 2 and object 1. So we don't need all of the elements. We are only going to look at this lower triangular part, or we can also look at just this upper triangular part as well. So basically, if our goal is to do clustering, we don't need this original data. All we need is the distance matrix corresponding to that data set. Why am I saying this? Because hence onward, we're just going to work with distance matrices. So, but it's important to keep in mind that the distance matrix comes from some data set. So it's possible that I either give you a distance matrix and ask you to do the clustering, or I'll give you a data set. In that case, you'll calculate the distance matrix from the data set and then do the clustering, right? But the main thing is this distance matrix. So we looked at agglomerative, or we looked at hierarchical clustering in the previous video, and we saw that there were 2 approaches, right? Agglomerative or divisive. So we are going to look at agglomerative clustering in this video. So it involves a bunch of steps. Step 1, we start with n clusters. So remember, we pretend that each element is its own cluster. Then we combine, in step 2, we combine the 2 most, the 2 nearest clusters. In step 2, we search for the nearest clusters. In step 3, we merge those clusters, say U and V. Then we update the distance matrix. So basically, this is the distance matrix between the clusters. And then we basically keep repeating this step 2, 3, and 4. That is, we find the next closest clusters, combine them, update the distance matrix. Then we combine again for the clusters, and we keep combining till all of the clusters are pushed into till all of the elements are pushed into a single cluster, right? So if you remember from the previous videos, we had a bunch of animals and a bunch of plants, and we kept on clustering till finally all of these elements were in a single cluster. Okay, so that is agglomerative clustering. So basically, so in step 6, so depending on how the distance between the clusters is calculated, we get different kinds of agglomerative clustering. So in agglomerative clustering, idea is the same. We start by putting each element in its own cluster, and we keep combining till all of the elements go in a single cluster. But how do we calculate the distance between the clusters? This will determine the type of agglomerative clustering method. So we have three types of these methods: that's single linkage, complete linkage, and average linkage. So in this video, we will be studying single linkage, and complete and average linkage. We'll look at it in another video. So agglomerative clustering, single of this kind, single linkage. So the basic difference, the main thing that separates this single linkage from the other agglomerative clustering methods is the method of calculating distance between the two groups. So let's see, I have two groups, X and Y. Group 1 has two elements, right? Each row is an element. So I have X1 and X2. Y has two elements, Y1, all the elements in this first row, Y2, all the elements in the second row. So the distance between these two groups, X and Y, is minimum of distance between of all of these pairwise distances. So dx1 y1 is just the Euclidean distance between this element and this element. X2 y2 is just the Euclidean distance between this element and this y2. So if I calculate all of these distances, I take their minimum. That is the distance between the two clusters. So basically, in single linkage, distance between two groups is the distance between their closest members. In our case, X1 and Y1 are the closest members because their distance is the smallest. So the distance between the two groups is also the same as distance between X1 and Y1. So now we'll work in detail through an example of how this clustering proceeds, okay? So this is a distance matrix. So remember, I don't need to have an original data. For clustering, all I need is a distance matrix that corresponds to the original data. So this distance matrix has 1, 2, 3, 4, 5. It has 5 elements. Remember, I don't need this complete matrix. Just this lower triangular part is enough because this matrix is symmetric. This distance matrix corresponds to a data which has 5 rows or 5 elements, right? So I have 5 elements in my data, and this is a matrix that gives me distances between each pair of elements. Okay, so this is a distance matrix. I'm going to note it by D. So which items are the closest to each other? So which two items should we group together? So this 2, right? So this is the smallest number. That is, items 3 and 5 are the closest to each other. So we merge these items. So now I have 4 clusters. I have one cluster with element 1, another cluster with element 2, another cluster with element 4, and then 3 and 5. This is agglomerative clustering. I'm starting by having all of these 5 elements in their own clusters. Right now, I've identified the closest 2 elements, closest 2 clusters based on the distance matrix, and I have merged them together. So clusters 3 and 5 are the closest because they had the closest from this distance matrix. I merged them together. So now the question is, okay, so we have this new group structure. Now first, then which 2 elements to combine next? So before that, we need to update this distance matrix, right? Now, no, we no longer have these 5 elements, right? We no longer have 5 clusters. We have only 4 clusters. So we need to update the distance matrix. So basically, distance between, so groups 1, 2, and 4 are the same because we have not changed anything about them, but things have changed about 3 and 5, right? So we are going to calculate the distance between this new group 3 and 5 and the other groups 1, 2, and 4. So let's see here. Distance between group 3 and 5 and 1, right, according to the exercise that we saw earlier, is the minimum of distances between all of its elements. So minimum of distance, so minimum of D31, that's distance between 3 and 1, and 5 and 1. 3 and 1, let's see, distance between 3 and 1 is 3, distance between 5 and 1 is 11. Minimum of these two is 3, so distance between cluster 3, 5 and cluster containing 1 is just 3. Distance between cluster 3 and 5 and 2, okay, so let's see. I need to look at distance between 3 and 2 first, and then 5 and 2. 3 and 2 is here, it's 7. For 5 and 2, the distance is 10. Again, we take the minimum, so that's 7. And similarly, we can calculate the distance between group 3, 5 and 4 to be 8. Next, we update the distance matrix, okay, here. So I have this new clustering structure. I have this 3 and 5 are in a single group. I have then clusters containing 1, 2, and 4. And this is the distance matrix. Now we are ready to see which groups should we, or which elements should we cluster next. Yep, this is the minimum element 3, that's the smallest distance. So that means we combine the groups 3, 5 and the group containing 1. Okay, so basically we need to now calculate the distances, right, and update the matrix again. Okay, so we need to calculate the distance between this new group that we formed earlier, right? So we combine 1, 3 and 5. So we need to calculate the distance of this group from the other groups. Now the only other remaining groups are 2 and 4 because 1 has been absorbed in this group here. Yeah, so distance between group 1, 3, 5 and 2, we need to look at distance of all of the elements in this group and this group. So let's see. So 1, 3, 5 has this 3, 5. I have this here. So distance between 3, 5 and 2, which is 7. And then distance between 1 and 2 here, which is 9. So minimum of 7 and 9 is 7. So distance between 1, 3, 5, this group and this group 4. So let's see, this 1, 3, 5. So I have this 3, 5 and 4. So distance between 3, 5 and 4 is 8. And 1 and 4 is 6. The minimum is 6. So now we are ready to update our distance matrix with these new distances. So this is the distance matrix. So now basically we have only 3 groups left, or 3 clusters. And so now we are ready to cluster the next step of clustering. So which group should we cluster next? So locate the minimum item. So that's 5. Let's see. So you can see that this is the minimum element here. So basically we should be grouping elements 2 and 4. Okay, so again we need to do the same thing, calculate distance between this new group 2 and 4 and all the other groups. So basically the only other group left is this 1, 3 and 5. So we need distance between 1, 3, 5 and 2, 4. So let's see. So I have 2, 4 here. I have 1, 3, 5. So basically I can only calculate distances between 1, 3, 5 and 2. 1, 3, 5 and 2, which is 7. 1, 3, 5 and 4, which is 6, and the minimum of the distances is then 6. Okay, so we have this updated, so we have calculated distances between all the groups. This is the updated distance matrix. So we have 2 groups, right? Distance between the 2 groups is 6. Which group should be clustered next? This is pretty obvious. So we have only 2 groups remaining, so we cluster them, and then finally once we cluster 1, 3 and 5 and 2 and 4, we get all of the elements in a single cluster, and this is the end of the algorithm. Okay, so this image here is a dendrogram, and this is a pretty cool way to visualize this entire clustering process. So remember, so you can see this as a single linkage method. So we first combined 3 and 5 in the first step. then we combine 1 with 3 and 5, then we combine 2 and 4, and then we combine the whole thing. So this kind of shows you the path of this entire clustering process. So this is all about single linkage clustering. In the next video, I will talk more about the other kinds of clustering, agglomerative clustering methods. Again, so basically the complete linkage, the complete linkage and the average linkage methods.